Hello and welcome. So today we're going to be talking about finding x and y intercepts. So the goal is I can determine x and y intercepts given the equation. Alright, so this first bit here is just a reminder, right? So you have your quadratics, ax squared plus bx plus c equals 0, right? And then you have your four solving methods. So you have your solve by a square root. If your bx term is missing, that's what you do. Alright, solve by factoring is always an option, right? If it is factorable, solving by factoring, totally a thing. Okay, if it's not factorable, you can always use solving by completing the square or quadratic formula. Alright, so just a reminder on those. Okay, so a coordinate point is a point x comma y. Alright, that's how you write it. You have x comma y. That is what we call a coordinate point. Alright, an x-intercept is a coordinate point, so x comma y, where the graph crosses the x-axis. Alright, an x-intercept can also be called a root, a solution, or a zero. Okay, so if you say x-intercept, that's the exact same thing as saying a root, solution, or zero. Literally, all four of these mean the exact same thing. Alright, all four of those are talking about the exact same thing. Okay, now we write those x-intercepts as the coordinate point, whatever your x value is, comma 0. Because if it's crossing the x-axis, right, a point where it's crossing the x-axis, what is your y value all along this entire line? It's 0, right? So you'll always have comma 0 whenever you're writing an x-intercept. Alright, so example 1. So find the x-intercepts. Alright, so what that means is we need to set y to 0. But we're looking at this and we say, oh, hold on, I do not see y anywhere. Well, fun fact, f of x is the same thing as y. This is the same thing as saying y equals x minus 5 quantity squared minus 3. Right, that is what this is. So f of x is the same thing as saying y. So we set that to 0. And then we have x minus 5 squared minus 3. Okay, and that's all we're doing, is we are solving now to find that x-intercept. So we need to solve for x. So, okay, I look at this and I'd say we only have literally one x. We do not have that bx term. So I'm going to solve by square root here. That's going to be the fastest method. So that means I need to get my squared stuff alone. So we have 3 equals x minus 5 squared. Alright, there's nothing else next to it, so we take the square root of both sides. When we do, we remember that plus or minus. Okay, so now we have plus or minus square root of 3 equals x minus 5. And when we solve for x, we add 5 to both sides. And so then we have x equals 5 plus or minus square root of 3. Those are your solutions. So now you have solved for x, now you write it as that coordinate point. So your first value of x is 5 plus that square root of 3, comma 0. That's literally your first value. It's your first solution. And your second solution is going to be 5 minus the square root of 3, comma 0, right? This is 0.1, 0.2. Right? Now this comma in between is just saying you have two different things. So your x-intercepts are going to be 0.1, comma 0.2. Now your homework is going to be asking you to write your x-intercepts as a list, so you'll just need that comma between. And that's it. That would be your answer. No, those are your x-intercepts. Okay, so it's really just Unit 5 in a nutshell. Solving for x and then writing them as whatever your solution is, comma 0. Alright, let's do another. So f of x equals negative 2 times x minus 2 times 2x minus 5. Well, notice right here, this is already factored, right? This is if we had already factored and then we had parentheses times parentheses, right? At this point, we're on step 3 for solving by factoring. That's going to make life so much easier because then we set each factor equal to 0. Now remember, a factor is the stuff with x's. So we have x minus 2 equals 0 and 2x plus 5 equals 0. Because when you solve for x, we get 0 equals negative 2, x minus 2, right? 2x plus 5. Okay. Now, some of you are wondering, whoa, what about this negative 2 out front, Miss Diddy? What does that do? Well, if you literally set this to 0, like -2 equals 0, well, can we do anything else to that? No, right? There's no x. There's nothing to plug in. There's nothing to solve for. Literally, this is saying -2 is 0. Is that true? No, right? -2 is not 0. So that -2 has absolutely no play on any solution. It's pretend it's not even there because it will have nothing to do with what you're doing, which is solving for x, right? You solve for x by setting stuff with x's equal to 0. Okay? So we add the 2 over to the other side. So we get x is 2. We subtract the 5. Then we get 2x is -5. Divide by 2. And we get x equals -5 halves. Those are your solutions. You write them as points. So your x-intercepts is that you have 2, 0, first point, right? It's whatever your x value is, 0. And you also have -5 halves, 0. Answer. Done. Okay. Oh, I accidentally skipped this. By setting y to 0. Whoops. Wink, wink. My bad. Y to 0 and solving. Alrighty. So that is the first portion. So let's keep going. We have 2 more. So now we have f of x equals x squared minus 6x plus 9. So we first started off, right, set our y, or in other words, your f of x, to 0. So we have x squared minus 6x plus 9. Alright, so now we need to solve for this. We have a couple of options. We do have the bx term, so solving by square root is out. So we can either solve by factoring, completing the square, or quadratic formula. Now, because I enjoy factoring, I find it really quick, I'm going to factor this. Alright, you'll notice that your a is 1, so we can totally use the shortcut here, right? 2 signed numbers are your factors. So we get -3 and -3 is your 2 numbers, because -3 minus 3 is -6, right? -3 times -3, positive 9. And because your a is 1, right, your number in front of your x squared is 1, we can literally do x minus 3 as your 2 parentheses. Now this is a weird case, because now our next step is to solve for your x's, right? Set each parenthesis equal to 0 when you're solving by factoring. So we get x minus 3 equals 0 twice. Meaning that when we add that 3 over to the other side, we get x equals 3 twice. Now that doesn't mean that you have 3, 0 twice. It literally means that when you are doing this, your x-intercept, you only have one of them. You only have a 3, 0. That's it, right? You'd never write it twice. Answer, you'd only have one. Because writing 3, 0 again, that's 100% redundant, right? We already know 3, 0 is an x-intercept. It's not going to cross at the same place twice. It's not going to, go down and, loop-de-loop and come back. Okay, that's weird. You will not see it. Okay, quadratics have a nice, U shape, as we talked about in transformations, right? This is never going to cross the same place and mysteriously loop. It wouldn't be a quadratic at that point. Okay, one last one. So we have D, f of x equals x squared plus 6x plus 10. Alright, so similar as before, I'm going to check factoring really quick. So we have 6 and 10. Well, the only thing that multiplies 10 is 2 and 5 and 1 and 10. And neither of these are going to add to 6, so factoring is not going to work. So it's either complete the square or quadratic formula. Now I'm a quadratic formula girl, so I'm just going to go straight into that. So we have x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now remember, where we got that a, b, and c from is that a is the number in front of x squared, so 1, b is the number in front of x, and c is your number at the end, so 10. Now if you forgot what that quadratic formula is, I did give it to you here. Alright, so you're welcome to do that. Oops, too far. There we go. Alright, and then it's just a matter of simplifying it down. So we get negative 6 plus or minus that square root. Now calculator time. 6 squared is 36 minus 4 times 1 times 10, which is 40. So it's essentially, apologies, so it's essentially 36 minus 40, which is just negative 4. So we get square root plus or minus square root of negative 4. 2 times 1 is 2. And then we just simplify from there. So first off, negative and square root, not a thing. We have to pull out the I first. So I comes out. We're left with a positive 4 all over 2. Alright, and then from there, we have negative 6 plus or minus, and then square root of 4 is literally 2. So we have plus or minus 2i over 2. You'll notice that 2 goes into every number here, right? 2 goes into 6 3 times, goes into itself once, So we end up getting negative 3 plus or minus I. Technically it's all over 1, but when it's all over 1, you don't have to write it. Okay, so those are your solutions. X equals this. Okay, so then from there, your x-intercepts are an interesting question. Imaginary number. Now, an imaginary number is not within the real coordinate plane, meaning that where, you have like 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5 in the negative direction. So you have negative 5 and 5, so on and so forth, right? Well, negative 3 would be, right there. But how do you do plus or minus I? The truth is, you can't, right? This is all real numbers. The only thing on this you can graph on an actual graph is real numbers. That plus or minus I isn't something you can do. Meaning, you do not have any x-intercepts. So yes, while you can solve for x, if you ever get imaginary numbers, you will not have x-intercepts. That means the graph will not cross the x-axis in the real number plane. Alright, so that is finding x-intercepts and writing x-intercepts. So thanks for watching.